So for golden section, it seems straightforward. You have these points, you do these points, you decide which way to go. What haven't we talked about to get golden section started? Well, we haven't talked about how to get that initial bracket where you know the minimum is within that, right? So the idea of bracketing, so we know the function value at alpha equals 0 usually. You have to try some alpha value, go out some amount. For reasons that we'll see later involving Newton's method, alpha equals 1 is often a good choice. So we'll just use that here. Suppose you saw this. So at alpha equals 0, our cross-section function had a value of 3. At alpha equals 1, the cross-section function has a value of 2.39. Have we established a bracket yet? Well, we have seen a decrease as alpha increases. That's good, but we haven't seen it go up on the other side yet. So the minimum might still be out farther than alpha equals 1 in this situation. So what would you do? Try a larger alpha. You could try 2. Sometimes just doubling the alpha will be a good idea. In some sense, there's a trade-off. You want to find that end of the bracket quickly, so making alpha bigger and bigger quickly is a good idea. But you don't want to go so far that you go way past the minimum. So it's kind of a tunable parameter. Do you want to add 10% each time? Do you want to double each time? There's no hard and fast guidance. But here, would you say we're done finding our bracket? Well, we saw the objective function decrease and then decrease again, but we haven't seen it increase again. So maybe I'd double the previous alpha value. And now it started increasing again from what we saw. So we've established our bracket. And our bracket here would be what set of alpha values? It would be from 1 to 4, right? Because the minimum could have actually been in between these two, and then it just started increasing by the time it got to 2. Or it could be between 2 and 4. So that's the basic idea of bracketing. What would you do if you saw this? Well, we started at an objective function value of 2. This is a different function than this. And by the time we got to 1, the total objective function had increased. So that means the minimum is between 0 and 1. And so we're done bracketing. What could possibly go wrong? That's a question we can always ask ourselves. Well, maybe we chose a search direction that isn't actually a decrease. And so no matter what your bracket, you would never find a minimum you would just keep finding the objective function increasing. So some software gives an error code when that happens. When it runs line search, it just can't find a point better than the current point. You must have given it a direction that's not an actual descent direction. So that's something to keep in mind. Here's a mystery to get you thinking about the next video. So far, golden section has asked, is this point higher than this point, and does that give us kind of a U-shaped thing? But other than this being higher than that, we haven't used the actual y values, like being a little bit higher versus a lot higher. We haven't used that information. So think about how we might do that, and we'll talk about that in the next video.